Preeti reached the metro station and found that the escalator was not working. She walked up the stationary escalator in time t1. On the other days, if she remains stationary on the moving escalator, then the escalator takes her up time t2. The time taken by her to walk upon the moving escalator will be. So these are ratios. Okay. So before solving this question, let me first draw a couple of diagrams. Well, actually, three diagrams to explain the concept clearly. Now let us say this is the escalator. Okay, so this is the escalator, and the length of the escalator is say, is there given any value in the question? No. So let us say it is s. Okay, so this much distance is s, this much distance is also s. Okay, now let us try to understand the given aspects of the question. She walked up the stationary escalator in time t1. Okay, so let us first assume that there is a person standing here, right? And the person is moving. Eventually, the person reaches the final point. Okay, so the same story repeats here too. The person is standing here, is moving, and he reaches the final point. The person reaches the final point. Now, let me denote the velocity of the person with the term Vm and velocity of the escalator with Ve. So velocity of escalator is Ve, velocity of person is Vm, or it is Preeti, right? So let us call Vp for better clarity. Vp. So we have Vp as the velocity of person, and velocity of escalator is V. Now, in case 1, what is the value of Ve plus Vp is equal to? See, Ve plus Vp in case 1 is equal to Vp alone. Why? Because the question says that she's walked up on the stationary escalator, which means value of Ve is equal to 0. Okay. Now, in this case, what is distance traveled is equal to? Distance traveled is equal to velocity into time, right? What is the distance? The distance traveled is s. What is the velocity? There is only one velocity, which is Vp. So Vp into time. It is said in the question that the escalator takes up in time t1, right? So this is first relationship. Okay, so we got one relationship, s is equal to Vp into t1. All right. Now in the second case, what is the equation again? Velocity of escalator plus velocity of person is equal to, see, if you understand the second statement, it says that if she remains stationary, which means if Vp is equal to 0, then the only component of velocity, velocity acting is velocity of escalator. Again, this escalator is moving with some velocity, so it will cover some distance. So distance is equal to velocity into time. And what is the distance here? The distance remains the same, which is s, and is equal to, so I think I would use this arrow. So here what it denotes is the escalator is moving, and here the person is moving. In the second case the escalator is moving, and in third case we have both escalator as well as the person moving. Okay, so the distance will be equal to velocity into time. What is the only velocity here? Ve, which is velocity of escalator, into time. It is given that it takes up in time t2. So what we get is Ve into t2. All right. So let us highlight that part also. Now if we try to understand the third part, what is the velocity, or say, or let me introduce, let me say V net in every case. So V net is equal to sum of two velocities, right? So V net is equal to Ve plus Ep in every case. Similarly, what we can say is V net in this case is equal to Ve plus Vp. But are any of them 0? No, because it says that the time taken by her to walk up on the moving escalator. So moving escalator means Ve is not equal to 0, and walk up means V of person is not equal to 0. So both of them have a velocity. In this case, what is distance is equal to? See, distance here will be equal to velocity into time. So what is distance? Distance now again remains the same. S is equal to, what is velocity? Velocity is V net. And do we know the time? We don't know the time. Let us say time. Okay, let us put time of both, or let us say time t is equal to. Okay. Now, what is V net? V net is Ve plus Vp whole into t. Now, what is the value of Ve and what is the value of Vp? See, from the first equation, what is Vp is equal to? Vp is equal to S by T1. So here we can write this as Vp, right? Vp is S by T1. Similarly, from the second equation, what can we write? Ve is equal to? Ve is equal to S by T2. So here we can write S by T2. The whole into T is equal to S. So now if you divide the entire equation by S, what do you get? So this is the equation we have. So if you divide the entire equation by S, so you get S here, T2 into S here, T1 into S here. So what you get is 1 is equal to 1 by T2 plus 1 by T1 into T, right? So we need to make use of that equation again. So 1 by T will be equal to 1 by T2 plus 1 by T1. So 1 by T will be equal to T1 plus T2 the whole upon T1 T2, in which case what is T is equal to? T1 T2 the whole upon T1 plus T2, which means the correct answer is option B. Now I would suggest that we try to understand the question in a better sense by actually considering an example, a practical example. Say okay, let us consider 3 examples here also. Say 3 cases here also. Case 1, case 2, and case 3. There's a person standing. There's a person standing. There's a person standing. In the first case, only the person moves. Second case, only the escalator moves. And in the third case, both the person as well as the escalator moves. And for a reference, let us take the velocity of person to be 5 meter per second and velocity of escalator to be 2 meter per second. Okay. And let the length of the escalator be 10 meter, right? In which case, okay, so this doesn't make sense, because the first case is that the escalator is stationary. So we have Vp and Ve. So V here is equal to 0. Second case, what happens is the person is stationary. So Vp is 0. And say the escalator is moving with 2 meter per second. The distance remains the same here, 10 meter. But what's conceptual to understand is that in the third case, the escalator is moving with 2 meter per second, which definitely means that the velocity of any person standing still, I repeat, the velocity of any person standing still on the escalator would be 2 meter per second. But in this case, the person is not standing still, he is walking along the escalator, which means here what will happen is the person will give an additional component of velocity, and therefore the person will feel some velocity is being added, his velocity on top of the velocity of the escalator. So this is the fundamental concept to understand. Just if you ask me, the takeaway lesson from this is to understand that when a object is moving and if a person is stationary on that, I think I can explain that diagram again. So this is a moving object, say velocity with VO, and if a person is standing still here, velocity of the person will be equal to velocity of the object, no doubt about it. Now, when this is a moving object and it's moving with velocity VO, and when the person is moving within the object with velocity Vp, the net velocity what this person will feel will be equal to Vp plus V0. Okay, so in this case, again the displacement remains the same, which is 10 meter. Okay, so what is time here? T1 would be equal to 10 by 5, which is 2 seconds, right? So if the person walks on the escalator, he will on the stationary escalator, he will take 2 seconds to complete the motion. Okay, now what is T2? T2 means 10 by velocity of escalator alone, which is 2 seconds. So if the person is standing still on the escalator, only due to the presence of him being escalator, he'll attain a velocity which is the velocity of the escalator itself, and it will take him 5 seconds to reach. But when he is moving along with the escalator, what happens is the T2, or say T is equal to, here becomes 10 by, it becomes 5 plus 2, which is 10 by 7. Well, in this case, it's 1.10 is 1.3, so 1.4 seconds, right? So what is the inference? The inference goes like this. If he moves on his own, he takes 2 seconds. If he moves with the help of escalator, it goes for 5 seconds. And when he moves along with the escalator, he takes less than that time as taken by him on moving alone, which explains the concept that the velocity is being added when he is moving on a moving object. Well, I think this explanation is too deep. It is too basic. I've made it as elaborate as possible, because at times simple things do take more time to explain. Having said so, let's move on to the next question now.